Section 14.6, Rational Exponents. In this video, we are going to understand the meaning of the nth root. We're going to translate expressions between radicals and rational exponents, and we're going to simplify expressions using the properties of rational exponents. So let's first talk about what we mean by nth roots and how we can write those in exponent form. So if n is a positive integer, then we write the nth root of a as the radical with an index of n, and then a is your radicand, and that's also understood to be a to the 1 over n. So our exponent becomes a fractional exponent. Now we are assuming that the nth root of a is a real number. There is a couple things we need to note about our index n. For this to be a real number, the nth root of a to be a real number, if a, the radicand, is not negative, so in other words, it is 0 or positive, then your index can be any value. But if a is negative, so if your radicand is negative, then n must be odd. So we've already discussed this. We don't want to do the square root of -4, where the index is 2 and the radicand is negative, because we've talked about that that is non-real. So if you want your answer to be a real number, then your index has to be odd when your radicand is negative. Let's apply the nth root to some problems and simplify. So if I have 49 to the 1/2, we understand that that means I'm doing the square root of 49 because my index is 2, and we previously discussed that when your index is 2, you don't write it. And we know that the square root of 49 is 7. 81 to the 1/4 is the 4th root of 81. Now again, as we talked about before, if I don't know the 4th root of 81, one of the things I can do is just break that up using the prime factorization and get that that's really the 4th root of 3 times 3 times 3 times 3. But since it's a 4th root, that group of 4 3's will give me 3. So the 4th root of 81 is 3, because 3 times itself 4 times will give you 81. -8 to the 1/3 is the same thing as the cube root of -8, which is -2. 0.00001 to the 1/5 would be the 5th root of that, which would be 0.1, because 0.1 times itself 5 times would give me that value. And -16 to the 1/2 is the square root of -16, but we know that that is non-real. So let's take a moment and go back and review our rules of exponents. The first rule says the exponent of 1, if you have a, that's the same thing as a to the 1st. So we know that 2 is the same thing as 2 to the 1st. The exponent of 0 rule says as long as a is not 0, then a number to the 0 power, or a variable to the 0 power, is 1. So we know that 4 to the 0 is 1. The product rule says that if you're multiplying with like bases, we add exponents. So if we have x cubed times x squared, we would get x to the 5th. In the quotient rule, when we divide with the same bases, we subtract exponents. So x to the 7th over x to the 4th would be x to the 3rd. Our negative exponent rule says if you have a to the -n, that's 1 over a to the n. So if I had x to the -2, that would be 1 over x to the +2. Or if you have 1 over a to the -n, so if your negative exponent is the bottom, it becomes a positive exponent in the top. So if I had 1 over x to the -3, that would become x to the +3. The power rule says that if you raise an exponent to another power, that you multiply exponents. So x cubed to the 4th would be x to the 12th. The power of a product says that if you have a product being raised to a power, you just raise each of those values to the power. So if I had x, y to the 5th, that's x to the 5th, y to the 5th. And then the power of a quotient says the same thing, but for division. If you have a fraction raised to a power, you raise the numerator to the power over the denominator to the power. So 2/3 cubed would be 2 cubed over 3 cubed, which would be 8 over 27. Now, if n is a positive integer and m is any integer, and a to the 1 over n is a real number, so it's been defined that you can find the nth root of a, then a to the m over n is defined as a to the 1 over n times, or to the m, but remember that when we raise a power to a power, we multiply exponents, so that would give me 1 over n times m would be m over n, or it could be a to the m to the 1 over n, which again would be the same thing. M times 1 over n would give you m over n. In radical notation, that looks like this. A to the m over n is the nth root of a to the m, or the nth root of a to the m. So really what we're talking about is what happens when you're doing fractional exponents. If you had x to the 2/3, what does that mean? Well, that means that the bottom number is the root you're going to be taking. You're going to be taking the cube root of x and squaring it, or you can do the cube root of x squared. Both of those will give you the same answer. That's all they're saying. A fractional exponent, the bottom is the root that you're going to be taking, and the top number is the power you're going to raise it to. Now let's look at converting between exponential and radical notation. So if I have x to the 2/3, we just discussed that. That means we're going to be doing the cube root of x squared. If I have 3 times x to the 4/5, now the 3 is not being raised to a power, so that would be 3, and then the 5th root, the bottom is the root, just like the root is at the bottom of a tree or the bottom of a plant. The root's at the bottom of the fraction, so it's the 5th root of x to the 4th. Negative a to the 3/2 would be negative, and then the square root of a cubed. Now if I do the 6th root of a to the 5th, that's a to the 5/6. The bottom is the root, the top's the power you're raising it to. 5 times the square root of x would be 5x to the 1/2. Because remember, your index is a 2. And negative cube root of 4 would be negative 4 to the 1/3. Now let's apply our rules of exponents to some of these problems. So here we have x to the 2/3 times x to the 1/6. Well, remember we discussed that our rule says when we are multiplying exponents or multiplying with the same base, we add exponents. So we want to take 2/3 plus 1/6 and add that. Well, that's the same thing as 4/6 plus 1/6. Remember, we would multiply by 2 over 2 to get our common denominator to be 6. So that's 5/6. So this would be x to the 5/6. In this problem, we're subtracting exponents. So I want to take 3/4 minus 1/3. So if we get our common denominators, which would be 12, I'm going to need to multiply this by 3 over 3, and my second one by 4 over 4. So I get 9/12 minus 4/12, which would be 5/12. So this is x to the 5/12. In this next problem, we're taking the product and raising it to the 3rd power. So this becomes 2 to the 3rd and a to the 1/4 to the 3rd. But 2 to the 3rd is 8, and a to the 1/4 to the 3rd is a to the 3/4. In the next problem, we're doing the same thing. We're doing 27 to the negative 1/3, y to the negative 9/10 to the negative 1/3. Well, 27 to the negative 1/3 is 1 over 27 to the 1/3. And then y to the negative 9/10 to the negative 1/3, we're going to multiply those exponents together and get y to the 3/10. So that's going to be 1 over the cube root of 27 times y to the 3/10. But the cube root of 27 is 1/3. So I get 1/3 y to the 3/10. And then 9 to the 2/4 is the same thing as 9 to the 1/2. But that's the square root of 9, which is 3. In this next problem, we're going to raise everything to the 1/2. And really, if we think about that, that means that we're doing the square root of all of that. So let's just go ahead and write that as the square root of 49, x to the 6, y to the negative 2, over z to the negative 4. Now what I'm going to do is I'm going to go ahead and move my negative exponents and make this 49 x to the 6th, but y to the negative 2 will go to the bottom and become y to the positive 2, and z to the negative 4 goes to the top and becomes z to the positive 4. And now we can start taking square roots. So this is the square root of 49, which would be 7. The square root of x to the 6 would be x cubed, because if you remember when we did that before, we had 6 x's spread out, but each pair gave me an x. So that's how I got x cubed. Z to the 4th would be z squared, because there would be 2 pairs, and y to the 2nd would be y. In this example, we're going to simplify each expression by first of all changing it over to fractional exponents, simplifying, and then we're going to change it back to radical form. So the first problem we're going to do is the 4th root of the cube root of x. But remember that the cube root of x is the same thing as x to the 1/3. But then I want to raise that to the 4th root, or take the 4th root of that, which would then mean that I'm going to raise that quantity to the 1/4. But then we know that there's a rule that says when we raise a power to another power, we multiply exponents. So that would be x to the 1/12, but in radical form, that would be the 12th root of x. In our next problem, we've got the cube root of a, which is a to the 1/3, times the square root of a, which is a to the 1/2. But we know when we multiply, we add exponents, so we want to take 1/3 plus 1/2, and when we multiply that, we get 5/6. So this would be a to the 5/6, but back in radical form, that would be the 6th root of a to the 5th. In our last problem, we're going to take the square root of x cubed and write that as x to the 3/2. Then the cube root of x squared is x to the 2/3. And we're going to divide that by the 5th root of x squared, which would be x to the 2/5. So I'm going to multiply these on the top. So I want to add 3/2 plus 2/3. So that's going to give me 9/6 plus 4/6, which will be 13/6. So the top is going to be x to the 13/6 over x to the 2/5. But now I need to subtract 13/6 minus 2/5, because when we divide, we subtract exponents when they have the same base. So my common denominator on that is going to be 30. So we'll multiply the first one by 5 over 5, and the second one by 6 over 6. So I'm going to get 65 over 30 minus 12 over 30, which is going to be 53 over 30. So my final answer is x to the 53 over 30.